Hi everyone, my name is Khalil Nini and I'm a PhD candidate in computer science at UC San Diego. Today I'm going to introduce our paper, A Gradually Soft Multitask and Data-Augmented Approach to Medical Question Understanding. This work has been done in collaboration with Adobe Research. So first I'm going to talk about the importance of question understanding. In order to retrieve relevant answers, one of the basic steps in question answering systems is understanding the intent of questions. This is particularly important for medical QA systems, as consumer health questions asked by patients, may use a vocabulary that's distinct from doctors to describe similar health concepts. Consumer health questions may also contain peripheral information like patient history that are not necessary to answer questions. So what is question understanding here? So question understanding encompasses the tasks of question summarization and recognizing question entailment. The input to both tasks is a pair of medical questions. The first question is called a consumer health question, or CHQ, and the second question is called a frequently asked question, or FAQ. The CHQ is written by a patient and is usually longer and more informal, whereas the FAQ is usually a single sentence question written by a medical expert. The purpose of both tasks is to match a CHQ to an FAQ and ultimately to an expert written answer that matches the FAQ. Medical question summarization is the task of summarizing consumer health questions into short, single-sentence questions that capture essential information needed to give a correct answer. The task of recognizing question entailment, RQE, is defined in the medical domain as a binary classification task. For the purpose of this task, a first question is considered to entail a second one, if and only if every answer to the second question is a correct and either full or partial answer to the first question. So we find in initial experiments that RQE can teach question summarizers to distinguish salient information from peripheral details, and likewise that question summarizers can benefit RQE classifiers. In our setting, we cast the medical question understanding task as a multitask learning problem, or MTL problem, involving the two tasks of question summarization and recognizing question entailment. In this paper, we introduce a novel, gradually soft multitask and data-augmented approach to medical question understanding. So we first explain the relationship between the two tasks and how they're equivalent. Let's assume C and F are two questions where C is longer than F. Question entailment is defined as question C entails question F, if and only if every answer to F is also a correct answer to C. According to guidelines set in the creation of a medical summarization, question summarization dataset, a good summary F should enable to retrieve complete and correct answer to the original CHQ. We therefore conclude that F is a good summary of C if and only if it enables to retrieve correct answers to C. It follows that F is a good summary of C if and only if C entails F. So our data augmentation method addresses a weakness in previous work in multitask learning, where each task involves a distinct dataset, often from a different domain. Our data augmentation will enable us to use datasets in the same domain, and we hypothesize that this can benefit performance in both tasks. For summarization datasets, we create equivalent RQE pairs. For each existing summarization pair, we first choose with equal probability whether the equivalent RQE pair is labeled as entailment or not. If it is an entailment case, we create an RQE pair identical to the summarization pair. To create an equivalent RQE pair labeled as not entailment, the RQE CHQ is identical to the CHQ of the summarization pair, and the RQE FAQ is randomly selected from the distinct question pair from the same dataset split. Inversely, for the RQE dataset, we create equivalent summarization pairs. For each existing RQE pair, we consider two cases. If the RQE pair is labeled as entailment, we create an identical summarization pair. If the RQE pair is labeled as not entailment, then we create a summarization pair that is identical to randomly selected and distinct RQE pair labeled as entailment from the same data split. In multitask learning, there are two widely used approaches, hard parameter sharing and soft parameter sharing. Previous work combining summarization and entailment proposes soft parameter sharing for all parameters except the first layer of the encoder and last layer of the decoder. MTDNN is a popular MTL model that set a new state of the art for the GRU benchmark and uses hard parameter sharing for all of the transformer encoder layers and only task-specific encoder classification labels, heads. We propose a hybrid approach where we apply hard parameter sharing for the encoder and a novel gradually soft parameter sharing approach for decoder layers. We define gradually soft parameter sharing as a smooth transition from hard parameter sharing to task-specific layers. It is a soft parameter sharing approach that is gradually toned down from the first layer of the decoder to the last layer, which is entirely task-specific. In gradually soft parameter sharing, we constrain decoder parameters to be close by penalizing their L2 distances, and the higher the layer, the looser the constraint. We use 4 datasets, 3 for question summarization and 1 for recognizing question entailment. MEXAM is a medical question summarization dataset released by the US National Institutes of Health. We extract the healthcare magic and clinic question summarization datasets from MedDialogue, a large-scale medical dialogue dataset collected from 2 online healthcare service platforms. Medica RQE is the recognizing question entailment dataset of the 2019 Medica shared task. Similarly to MEXAM, the question pairs match a longer CHQ received by the US National Library of Medicine and FAQ from NIH institutes. Our loss function has a hyperparameter lambda to balance the question summarization objective and the RQE objective. We run experiments where lambda varies from 0.1 to 0.9 in 0.1 increments. For the question summarization datasets, we notice that the smaller the datasets, the more it benefits from data-augmented MTL with RQE. We compare our data augmentation algorithm against the following alternative. Instead of training using a synthetic dataset for the auxiliary task, we choose a separate existing dataset for abstractive summarization, recognizing question entailment, or textual entailment rather. That is an approach that is taken by most MTL models. Our results show a consistent increase in performance across all datasets when using our data augmentation method, suggesting that in-domain MTL is more efficient. We compare our gradually soft parameter sharing method with 3 other parameter sharing configurations. For all configurations, we keep using our data augmentation method and sharing encoder parameters entirely. So our 3 baselines include hard shared decoder, a soft shared decoder, as you see here, and a task-specific decoder. And our results for our method exceed all 3 of the other parameter sharing configurations in RQE accuracy and some of the Rouge L F1 scores. These results show our proposed smoother parameter sharing transition between encoder and decoder layers brings about higher performance. So our model and baselines are based on BART. Models are BART trained just on the summarization objective, BART plus entailment generation, BART plus entailment generation question summarization, and the MTL configurations of both of these related works, and BART plus RQE and our gradually soft MTL. And our model is able to exceed the baselines in Rouge L. We hired 2 annotators to judge 40 sample summaries, 40 for each of the 3 data sets, that's 120 total. And scores generally favor our method, more strongly so in the abstractive data sets, MEXAM and Healthcare Magic. This is an example from the paper where we highlight 4 of the main components of the user question. These are present in the reference FAQ and in our generated summary, but not in the summarization loss on the baseline. So our question entailment results show a 12% increase compared to the BART single task training baseline, and it exceeds a baseline using BioBird and adversarial MTL with medical QA. Finally, so we compare our gradually soft MTL and data augmented method with a single task BART baseline on four low resource settings. On all four data sets, the scores of the single task BART baseline for 100 and 1000 data points are lower than or roughly equal to the scores of our method for a training subset of half the size. So in conclusion, we propose a novel multitask learning approach for medical question understanding. Our approach trains on the tasks of RQE and question summarization in a simultaneous weighted MTL loss function, where we add a loss term to constrain the decoder to be close, and we loosen the constraint gradually as we move higher up the layers. We compare our method to single task learning and existing MTL work and show improvements across 3 medical question summarization datasets and 1 medical RQE dataset. Finally, we test our approach under low resource settings. We find that it is able to efficiently leverage small quantities of data, and that these performance increases do not only depend on additional data from augmentation. Thank you for your attention. Here's my email for contact. We highly recommend that you check our other work on the question answering at ACL 2021, as well as our previous work on medical summarization and entailment from the NACL 2021 NLP MC and BioNLP workshops. Thank you.